Alright, so this is the first problem I'm going to be doing in section 10.4. In this section we're discussing all kinds of stuff to do with the area of polar curves and as well, I believe, the length of the curves. So for this first problem, it's pretty much just straight up integral really, because it's just a sector and it's giving you the angles. So to compute it, we're just going to plug in what they give us and evaluate the integral. We're going from 0 to pi over 6, and then it says within the formula that it's the radius squared. Radius is a function of theta squared. So our radius is cosine theta, so squaring that we just get cosine squared theta d theta. Now if you remember from the trig integral section, this is not something we can do directly. We have to use a trig identity. You may try using sine squared plus cosine squared is equal to 1. The problem with that is even if you did solve for cosine squared, you'd be left with the same degree sine, and it would just keep on going like that. So not the way you'd want to do it. Instead, the identity you want to use here is that double angle, I believe it's called, or maybe half. I think it's double. 1/2, and then you use 0 pi over 6. Then cosine squared can be written as 1/2 1 plus cosine of 2 theta d theta. And then that way we can factor out the 1/2 outside the integral and break it up into two different integrals using linearity, right? The 1 and the cosine theta. So we've got 1/4 the integral from 0 to pi over 6 of 1 d theta plus 0 to pi over 6 cosine of 2 theta d theta. Now this first one, the integral of 1 is just theta, so we just get pi over 6 minus 0, which is just pi over 6. And then this is a 4. And then for the second one, well, we can't, what we want to do, we could use u substitution, let u equal 2 theta and go out with that. But really, if you remember, when we have a coefficient inside the argument of integral of a trig function, we just divide by that coefficient and then use the appropriate sign depending on which function we had. So in this case, this will work because the derivative of sine is positive cosine. And you can check that if you're not convinced. 0 to pi over 6. And then from there, well, we've got pi over 24 for this first term, factoring that. And then from this one, well, we've got 1/8 from the 1/2 and the 1/4. And then we've got sine, so let's see, sine of 2 times pi over 6 minus sine of 2 times 0. That just goes to 0. So really we're just left with sine of pi over 3, which is square root of 3 over 2. And we have 1/8 of that plus pi over 24. So pi over 24 plus root 3 over 16. Common denominator is 48, so 2 pi plus 3 root 3 over 48. And that is the solution to this problem. Yes.